Hi everyone, today we're going to look at the half-life of silicon-32. It's an incredibly important isotope that acts like a natural clock for our planet. It helps scientists date everything from deep ocean crust to ancient glacial ice. Since silicon-32 has a half-life of 150 years, it's a great example for modeling changes that happen over several centuries. In this video, we're going to walk through the exact steps to calculate its rate of decay, then determine how much of an 80 milligram sample would actually remain after 450 years. To get started, we'll find the rate of decay of silicon-32. Because the rate of decay is so long, we want a lot of decimals in our answer, so we're going to give 6 decimal places. The formula we use for the half-life is T is equal to the natural log of 1/2 divided by R. Here, T is our half-life in years and R is the rate of decay. Let's plug in our 150 for the value of T. Now that we have 150 is the natural log of 1/2 divided by R, we can just rearrange our equation in terms of R. That says R is equal to the natural log of 1/2 over 150. We'll plug that in our calculator to get that R is negative 0.004621. Now that we have our rate of decay, we're ready to do our next calculation. If a sample of glacial ice contains 80 milligrams of silicon-32, how many milligrams will remain after 450 years? To solve this problem, we'll use the formula A equals P e to the RT. 80 milligrams represents P, the amount we started with. 450 is our time in years, and we have R from our previous calculation. Putting those values in our formula gives us A equals 80e to the negative 0.004621 times 450. So we have 80 e. When you hit the exponent, make sure you put in parentheses. That way, both the negative 0.004621 and our 450 for years are both in the exponent. That gives us 9.99999. We'll round our 9.999 answer to 10 milligrams as our final solution.